All right, welcome back. So far we've been looking at volumes with disk, where our cylinder that we were building was always connected uh, to the axis we were revolving about. We saw that in this example here when we were doing it about the Y, and on our previous examples, we were always connected. Uh, the area that we were rotating was always connected to the x-axis or the y-axis, depending on which one we were revolving about. But consider the situation here where we're looking at this area here, and we want to revolve that. Well, a disk isn't going to work now because if I did G, I would actually be getting all of the area beneath G would be coming in if I was using G as my radial function. Um, so the idea here is that we're going to, look at G, but we're also going to look at F and realize that in the cylinder, when we're looking at G here, let me actually fix this thing. My rectangle was a little sideways there. Fix that. So what we want is actually this piece right here is what we want to rotate. So what we realize is that when we do this, if we do it about G, we're getting this big cylinder. Right? We're getting this big cylinder. Again, I'm just going to make it a little taller than it usually would be. All right, and that's our F function, sorry, the top function. But then inside, I have a piece that I don't want in there, so I cut that piece out. Okay, and so what happens is my volume ends up being on that cylinder there, my volume ends up being the volume for G minus the volume for F, minus the volume for F. And so we use the F radius and we use the G radius. And so what that leads us to is this result for the volume with the washer is the integral across our interval, right, of pi, and then it's going to be the top function squared minus the bottom function squared, right? And then they both have the same height, delta x, so dx. So without going into the full detail, the idea is basically you're going to have the volume of the big cylinder, which again is F here, the F function, minus the little cylinder, the G function, and we just find it most convenient to write it this way. Okay, so this is the volume with washers. And it's a washer because what we're really looking at is a very thin thing with a hole in it. Okay, and we're going to have a whole bunch of those stack up to eventually give us our volume. So that's why it's called a washer.